Afternoon, everyone. My name is Cecili Poole, and today I'm going to talk about demystifying code through testing. I have a love of tests simply because I like to have confidence in the code that I write. I like to break things, I like to fix things, and tests are a way to ensure that I am not breaking production. You will notice I am not using slides, and that is because I want to challenge myself as a public speaker and see if I can get my point across without relying on slides and imagery. This is kind of a little bit of bad news for you all because that means I need some audience participation. I also need audience participation because no one told me pregnancy would be this tiring. And I am really, really struggling, and the tea hasn't kicked in yet. So I'm going to feed off of y'all's energy, okay? So to test out this audience participation, when I say refactor, you say tech, okay? Y'all with me? Refactor. Y'all can do better than that. Refactor. 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 Great. Surprisingly, that always works for me to get that energy from y'all. I feed off of y'all. But I'm not an extrovert, so don't get that twisted. Another part of this audience participation is to get to know y'all a little bit more. So if everyone can raise your hands, please, just one. I will point out some of this is how I also know if you're paying attention. So if you want a job at Netflix, this is, participate. No, I'm just playing. I have no promises. Anyway, if you have been working as a software engineer or done software development for more than 10 years, put your hands down. For more than 5 years. Okay, for more than 2. So we have a pretty interesting mix. Last question. How many of you have worked on an existing project, be it at a company, open source, with some kind of existing code base? Okay. There are actually a few of you who don't have your hands raised. I'm going to assume you are the lucky few who do greenfield projects and can always write new code. This talk isn't really for you, but hopefully you'll still get to know and learn something. So with that said, I'm going to talk about why we should even care about tests and why we should use them to better understand our code. I have 3 reasons. The first is it allows us to better understand our code when we may be lacking in documentation and understanding the business requirements. We've all probably worked on projects where someone just wrote something, did not bother to leave a comment and explain any of the complicated logic. But hopefully, if they wrote a test, you'll be able to understand at least what they were trying to do. This is also helpful if the code is spaghetti code and just horrible code. But hopefully, if the tests work, you have some kind of confidence in the code, and you can use those tests to better understand it. The second reason we should care about tests, especially in existing code bases, is because it's a great way for us to debug things. If something breaks in production, ideally, you don't want to try and reproduce it in production. But if you have a test that tests that code path and you are able to make those changes there and debug there, that is a wonderful and safe way to fix the issue that you're encountering. Reason number 3, and probably my favorite, and I've used this religiously in my career, is it is a great way to make an impact on your team pretty quickly. If you see, like I have before in my career, that it takes an hour for your test to run locally, and you're able to do something about that and get those tests down to 15, 20 minutes for your entire company, you immediately proven yourself and given some kind of value to your team and your company. Who knows, you might get a raise out of it as well. So there are 3 different scenarios I'm going to talk about, and I'll also share some of those action items for each of these scenarios. In every scenario, there's always some kind of opportunity to make some kind of difference. For the first scenario, you walk into a project or a team where they have absolutely no test. Now, if you love tests the way that I do, and you're in this situation, you may ask yourself, why? For the love of God, why do you have no test? How can you be confident in what it is that you're building, what it is you're writing if you have no test? And the dirty little secret is they use production for those tests. I'm not happy about that because that means some feature that someone else is working on could be impacting my money, my time, my on-call schedule. So in this situation, naturally, you want to add tests. There are 3 different ways or 3 different suggestions I have for you to go about adding those tests. I realize it's easier said than done to make such a change, but hopefully with these 3 words, you'll be able to make that impact and add some tests pretty easily. This is where audience participation comes in, and I want y'all to repeat after me. Why? Come on, give me the same energy from before. Why? Thank you. Buy? And set up. Wonderful. For why, we want to establish why it matters that we need to have tests in this code base and for this project. For buy, we want to get buy-in from our manager, our product manager, our teammates. And then for the setup, we want to do the legwork that no one else has obviously done to determine the test framework, the test suite, implement some tests, set up some examples, and maybe even set up your CI/CD pipeline in this project. I'll talk a little bit more about each of these in more detail. With the why, you want to focus on a particular problem or pain point. Bonus points if you can quantify it. Even better if you can associate that with money. So if you can say that that outage that we had last week that lasted for 10 hours cost us $50,000 and could have been prevented if we just had a test suite, there's no better reason than that to add a test for a lot of businesses. And that will make it easier for you to get buy-in from your manager and hopefully also from your teammates. You want that buy-in, especially from your teammates, because you can't write all of the tests by yourself. You could, but it kind of defeats the purpose, because what's going to happen is you write all of these tests, other people come along and write code, and they don't bother to write tests, and you're back in the same situation. So you want to use that why, that pain point, maybe not just the money, but also maybe your teammates are tired of the on-call rotation and how that is going. And you can get buy-in with them to help you contribute to these tests. Lastly, with the setup is where all of the power comes into play. You get to decide what the test suite and framework looks like. You get to decide what the best testing practices are. You get to hopefully ensure that moving forward, these tests are being created consistently. All right. So when you're in a situation when a code base has no test, you want to remember 3 words. What are they? Why, buy, and set up. Cool. You'll be doing this again one more time at the end just to be prepared, all right? The next situation is you walk in, you have a code base, and it has some tests, but they're horrible. They're sucky. They take hours to run, or they're inefficient, or they're flaky. You just don't like them, and you decide to improve them. Now, since it's 3 p.m. on a Friday, a couple hours before happy hour, I got creative with this one, so don't hate me, okay? My mnemonic device for this involves clapping. I'm going to demonstrate it once, and I'm going to expect y'all to do it with me twice, okay? Y'all ready? The 3 words I'm going to use for this section is metrics, test types, clean code. All right, y'all ready? I'm paying attention to who's participating. All right, we got some internships too. I might decide to refer y'all. I don't know. All right, you ready? 1, 2, 3. Metrics, test types, Clean code. Great. Thank you. Love it. I was so worried that wasn't going to work and I was just going to walk off the stage. So thank you all for giving me that energy. All right, so with metrics, there's a ton of different metrics that you can have when you're talking about running your test and testing your code. I'm going to focus only on two. The first being time, how long it takes the test to run, how long it takes your entire test suite to run, and the second being how many failures have occurred over a span of time. When we're talking about how long a test takes to run, you'll hopefully notice that maybe 90% of your tests are fairly fast, but 10% of them is just really dragging down your overall latency. Your report will hopefully show you that one test in particular is spending 50 seconds just in spinning up a database. Or maybe you have another test that's horribly written that someone decided to put a sleep timer in, which obviously is going to slow everything down. So using time is a really good starting place of identifying where your tests are going awry. For the second one, it's one that I don't think a lot of people pay attention to, but I particularly love it, is knowing how many failures have occurred over a span of time. Now, if you've ever had a flaky test or non-deterministic test, that is a test where you run it 1 second, it's completely successful, and then without breathing, without changing the code, anything, 50 seconds later, it decides to fail. Nothing changed. That is what we call a flaky or non-deterministic test. Now, those can be very tricky to figure out if it has some kind of random pattern, something that's going on. It becomes even trickier when it works on your machine, but it doesn't work on their machine. Or it passes in the CI/CD but fails for you, or passes for you but fails when you go and deploy the code. This metric of how many failures for your test have occurred over a span of time is a great way to begin to identify if you have a flaky or non-deterministic test. And I bet a lot of people didn't even know that was a metric that you could have. So both of these metrics are very helpful in pinpointing where in your test suite you should try and focus and make some improvements. Now the next part, test types. There are a slew of test types. There are unit tests, integration tests, functional tests, canary tests, smoke tests, behavioral tests. I'm probably forgetting some, but there are a ton of different test types. I'm not going to talk about all of them, but the main point I want to make about test types is you may find that some of your tests are supposed to be of one type, but they're masquerading as another. So for example, you may have unit tests that are supposed to be black box, isolated, fast, pretty simple, frequently run tests. You can also have integration tests that are run less frequently. They may use more resources, like spinning up an embedded database, making an over-network call, and ideally, they are run less frequently. There have been a number of situations I have been in where I think I'm running a unit test, but it's actually an integration test. So if you have 100 what's supposed to be unit tests, but they're all actually 100 integration tests, spinning up databases and making network calls, no wonder your tests are going to be slow and inefficient. So it's very important to understand these different test types, what the pros and cons are, when to use them, when not to use them. And it's also important to know that you don't have to have just one type of test. You don't have to just have all unit tests. There are going to be situations where you want unit tests, integration tests, canary tests to really cover your bases. What's important is to use the right test for the right moment. Lastly, we have clean code. So by clean code, I am referring to when your code has duplicate code or when it has a ton of dependencies and it's not organized very well. It's spaghetti code. It's just very difficult to manage. Themselves are also going to be difficult to manage. They're going to be difficult to maintain. Your code is going to be difficult to test. If you have a lot of convoluted conditional if statements, you're going to have a lot of possibly unnecessary tests. So one of the things to focus on is maybe question, is my code actually as clean as it could possibly be? If not, your tests are going to be horrible. With that, cool, I'm just chugging along here. I'm trying to get us back on schedule somehow. We'll see. Okay. So to recap, for the situation where you have tests, but they're horrible, crappy, slow, inefficient, you want to remember metrics, test types, clean code. Great. So on this wonderful journey, we've looked at a code base that has no test. We've dealt with a code base that has some tests, but they are bad. Now we're in the situation where you jump into a code base and they have good, reliable tests. Everything is wonderful. Someone before you did all of the hard work of setting up a decent test suite, great test framework. Your job is done. There's no point in talking about this, right? Wrong. Like I said before, there's always room for improvement. For this section, the phrase I want you to remember is consistent coverage. Repeat it. Consistent coverage. One more time, a little more energy. Consistent coverage. Thank you. You're a great audience. You really are. By consistent, I mean you want to stay consistent with the test practices that your team has already put into place. That does not mean you can open a PR of new code and ignore your tests and listen to the little devil that tells you they already have a bunch of tests. You don't need to look and check if you need to add any more. Don't bother. You don't want to be a bad coworker and just throw up a bunch of new code, but not even edit or add some tests. It also doesn't mean that you have to become a little dictator and demand that every pull request of new code, you are expecting a test, especially if it's something ridiculous like just changing the spelling of a string. That's a way to get your coworkers to hate you, guaranteed. So be reasonable, use your best judgment, make it make sense. Like if it's something that will break in production and really cause a problem, then add a test. Don't just decide everything needs to be tested. It's something that ideally you and your team will agree upon, and you'll be able to stay consistent within that. For the second one is coverage. Coverage I always like because a lot of people seem to go crazy for coverage. And by coverage, I mean the number of lines of code that are actually covered by tests, or the number of branches of logic actually covered by tests. Sometimes it'll show up in your metrics as a percentage. And the most helpful part to me is where it shows you some of your blind spots. You may think that you introduced new code, you added a test, and everything is adequately tested. But by looking at your code coverage, you will see that certain lines of your code wasn't tested at all. Code coverage is something to also be wary of, because since it is a metric that managers or product managers or other people can easily see and measure and latch onto, a lot of people are tempted to just add tests for the sake of adding tests. But that can actually backfire on you. Trying to get to 100% code coverage will likely mean that you're doing some crazy stuff in your test just to get to that 100% code coverage. So be mindful of that. Usually with your team, 80 or 90% of a code coverage is more than enough, and you just want to continue to be at that baseline as you're adding new code. Now, if you see that your code coverage is less than 50%, then that is a great opportunity for a newbie to the code base to make a difference and learn the code base, learn the test, and just add some to get that code coverage up. And again, it's oftentimes a metric that a lot of people like to look at, so you might get a lot of accolades if you're able to say, we had 15% code coverage, but I took my lunch hour or I took some extra time and really understood the code, and I brought our code coverage up to 75%. That can be pretty impressive. So if you are lucky enough to be in the situation of working with a code base that already has pretty good, decent tests, there's still a phrase that we all should remember to make some room for improvement. And that phrase is consistent coverage. One more time, consistent coverage. Thank you. I appreciate you. You're like, I was trying, can't remember. That's okay. By the end of this, you'll all remember, sure. All right, so all of this that I've talked about is just from my personal experience, my opinion. It's just the tip of the iceberg. You all probably have some other best practices, but hopefully walking out of this, you all have an understanding of why it's important to pay attention to your tests, especially in an existing code base. To do so means that you'll be able to better understand that code. You'll be able to safely debug it. You'll also be able to take advantage of some opportunities to improve that code base and make an impact. So quiz time for audience participation. Y'all ready? So you walk into your team meeting, you find out your project has no test. What 3 words should come to mind for you? Thank you. One more. Y'all got the same thing, but wrong rhythm. But let's do that one more time. I appreciate it. Why? By setup. I love it because I was hearing like a cascade of. All right, in the situation where you have tests that are horrible, bad, inefficient, slow, what phrase and words should you remember? You're my favorite. Let's do this one more time so I don't have to point out one person who remembered it. Y'all ready? 1, 2, 3. All right. I love that beat. It reminds me of like, I don't know what it is, but I'm like, no music, hey, hey. So I don't, anyway. The last question is, what is my last question? Scenario where you have a code base with stellar tests. What phrase should you remember? Great. Thank you so much for indulging me. I really hope that this has inspired you to go and do something about your tests, maybe spread the word, maybe makes you hate your tests a little bit less. I think we'll be doing questions later, and thank you.